Okay, so 8.3, showing that a quadrilateral is a parallelogram. So in the last section in 8.2, we talked about what makes a parallelogram a parallelogram. So now we're going to give you a quadrilateral, and you're going to be able to prove that it's a parallelogram by having certain features and properties. Theorem 8.7. So do I necessarily need for you to remember these numbers on these theorems? No, not necessarily. Do I need you to remember the content of the theorems? Yes, that's what you need to understand. So if both pairs of opposite sides of a quadrilateral are congruent, so this side is congruent to this side is congruent to this side, and they're both labeled, then this has to be a parallelogram. Okay? So that's theorem 8.7. So this guy is a parallelogram. 8.8 says if both pairs of opposite angles, so this guy of a quadrilateral are congruent, so this is congruent to this and this is congruent to this, then it is also a parallelogram. The next one states if you have one pair of opposite sides of a quadrilateral that are congruent and parallel. So it has to be the same pair of opposite sides. It has to be congruent. And then if you see, they have the arrow in here to show that they are parallel. That means that this is a parallelogram also. And then last, if the diagonals bisect each other on a quadrilateral, then it is a parallelogram. So these two intersect at this point. This point is the halfway point for this piece, and it's the halfway point for this piece. That does not mean that all four pieces are congruent. That just means that this is congruent to this, and this is congruent to this. Okay, so ways to prove a quadrilateral is a parallelogram. So essentially, everything we just wrote up here, or just stated, is down here. Which theorem can you use to show that the quadrilateral is a parallelogram? Well, this is 105, this is 75, this is 105. There's 360 degrees in a quadrilateral. So if I take 360, I subtract 105, 105, and 75, I get 75 degrees down here. So I can prove that this is a parallelogram by which theorem up top? And that is theorem 8.8. So go ahead and pause me and try 2, 3, and 4 on your own. Unpause me when you're done. All right, number 2. This one is saying that 98, 98, 73, 73 opposite sides are they're not parallel. It doesn't tell us that, but it does tell us they are congruent, which in turn makes them parallel also because it makes it a parallelogram. So this would be theorem 8.7. Next one is showing that this piece is 5, this piece is 5, this piece is 3.6, and this piece is 3.6. So the diagonals bisect each other, which makes this a parallelogram. That is theorem 8.10. And then the last one, they labeled one pair of sides as congruent because they're both 10 and parallel. So that would be theorem 8.9. Okay. Next one, for what value of the quadrilateral a parallelogram? So it is true that this and this are congruent to make it a parallelogram. But it's also true that these two together add up to be 180, okay? Half of that total number of degrees of the 360 of the quadrilateral. So your supplementary, or your adjacent angles are always supplementary. So this one would be supplementary with this would be supplementary with this, and this is supplementary with this. So if I know that these two are supplementary, that means that 8x plus 19 plus 21x minus 13, that has to equal 180 degrees. So that is 29x's. And that is plus 6. So 19 minus 13 is that plus 6 equals 180. I'm going to take my calculator and I'm going to do 180 minus 6, which is 174, and then divide by 29. So I get x equals 6. If x were 6, that would make that a parallelogram. Next one, they're showing diagonals. They're saying this is congruent to this, but this one always would also have to be congruent to this guy. If it's a parallelogram, they have to bisect both. So that would mean that 4x plus 15 would have to equal 10x minus 33. I'm going to subtract 4x to give me 6x. I'm going to add 33 to give me 48. Divide by 6, and I get x equals 8. Go ahead and pause me and try the next one on your own. Number 7, again, this angle and this angle, they are not congruent, but they are supplementary, and they don't look congruent, right? So this one's obtuse and this one's acute. I can't always go off that because it's not always drawn to scale, but it is a good way to sometimes check yourself. So I know that if I add these two things, it equals 180. So I'm going to go ahead and add them before I write them down. 10x's and 4x's makes 14x's. 1 and 11 makes 12. So I'm going to take 180 minus 12, and then I'm going to divide that by 14. So I get x equals 12. Okay. The vertices of a quadrilateral ABC are given. Draw the ABC or ABCD in a coordinate plane and show that it is parallelogram. So go ahead and draw and label your points for A, B, C, and D. Okay. So here's A, B, C, D. Hopefully yours looks similar to mine. Hopefully I graphed those correctly. If we think about this, the ways that I can prove that a quadrilateral is a parallelogram. One way is to prove that opposite sides are congruent. So this is the same length as this, and this is the same length as this. So that's one way. Another way is to prove that angles are congruent, opposite angles are congruent, but I can't talk about or figure out angles on a coordinate grid. Okay? Another way is to prove that one side pair that's opposite is congruent in length and is parallel. I could do that here because I could prove that they're length by distance, and I could prove they're parallel because if I have parallel lines, their slopes are congruent. What's the other ways that I'm forgetting here? Oh, diagonals. I could draw diagonals on here and then find the distance of the different pieces. So there's really three ways on a coordinate grid that you can prove them congruent. Some problems will be easier to prove congruency in a certain way than others. Like this one would be easier to prove that it is a parallelogram if I prove that this side, BC, is congruent to AD, and if I prove that it's also parallel. And the reason I'm going to choose this way is because to find the distance of this, I can just count it because it's straight on the line. So 1, 2, 3, 4, 5, 6. So BC is equal to 6 in length, and its slope is 0 slope. There's no rise. Then I'm going to do the same thing for AD. So 1, 2, 3, 4, 5, 6. So it's 6 in length, and it has a 0 slope. So I have proved that opposite sides are parallel and congruent. So this is by theorem 8.9 that ABCD is a parallelogram. Okay? Go ahead and pause me and try number 9 on your own. Figure out whichever way you want to do, whichever method you want to use to prove that it's a parallelogram, if it is. So I'm going to graph it. Oopsies. Okay. All right, on this one, I am going to do the same method because I'd rather do distance formula twice than 4 times. So I'm going to find AB and CD. First, I'm going to find their slope. I go rise 1, 2, 3, 4, 5, 6, and I run 1, 2. So if I rise, so this is AB, its rise is 6, its run is 2, so that's a slope of 3. CD, rise 1, 2, 3, 4, 5, 6, run 1, 2. If I would have gotten on that those aren't parallel, I could stop there and I could say that it's not a parallelogram. Okay, so I did that. So now I'm going to use the distance formula to find their distance. So remember, distance formula is big square root y2 minus y1, parentheses squared, plus x2 minus x1, parentheses squared. So I'm going to do AB. I'm going to do y2 minus y1, which is 2 minus a negative 4, which gives me 6. So 6 squared is 36. And then I'm going to do x's, negative 1 minus a negative 3, so that's really negative 1 plus 3, which is 2. 2 squared is 4. So this is the square root of 40. We're going to see if CD is the same. Use a different color so you can see it a little bit better. Big square root, y2 minus y1 is negative 6. Negative 6 squared is 36. Plus x2 minus x1, that's negative 2. Negative 2 squared is a positive 4. That gives me a square root of 40. So this side is parallel to this side, and it is congruent, so it is a parallelogram. I'm going to pause myself, and I want you to pause yourself, and I want you to try just number 10 on your own. Don't worry about doing number 11. I think 3 of these examples is plenty. I'm going to unpause myself whenever I'm done just to show you the answer. Okay, couple things here. This is not actually a parallelogram. This is what we would call a trapezoid. First thing I want to talk about is that they didn't even label it correctly and put it in the correct order. In the directions it says quadrilateral A, B, C, D. So it would have to go A to B to C should be here and D should be here, because remember we named it around in a circle. I chose to prove that it's not a parallelogram by using theorem 8.9 and saying, okay, are these two parallel and are they congruent? They ended up being parallel. They both have an undefined slope. So that's check mark number 1. But this has a length of 4 and this has a length of 6. Therefore, they are not congruent in length, which they would have to be to make it a parallel. So this one is actually not a parallelogram. Okay, so you have 2 assignments. The first one is your Schoology 8.3 assignment, and then the second one is doing 8.3 in your supplemental packet, pages 5 and 6. And then there will be a Schoology assignment to go along with that.